In this lesson, we're going to introduce 3D figures. So first thing we need to talk about is some different vocab or concepts that are associated with 3D. So the first idea here is a prism. So the difference between a prism, or you've heard of cylinders, cones, pyramids, spheres, what's the difference in all of these figures? So a prism is a three-dimensional shape that's made up of two congruent bases that have to be parallel to each other. So in a prism, you have two congruent parallel bases, also known as faces. So all of the polygons here that make up the three-dimensional shapes, we call those faces. When they are parallel and congruent, we call those bases. So if you look at this first one, this is going to be called a pentagonal prism because you have two pentagons that are parallel, and those two pentagons are congruent, parallel, and they're connected by all of these rectangles. So the rectangles are actually called the lateral faces. So remember, all of the polygons are called faces, but the two congruent parallel ones are bases. The lateral faces are the ones that connect those bases. And then the other thing to keep in mind here, the difference between an edge and a face. So an edge is going to be a line segment versus a face is the entire polygon. And then the vertex are all of these points where all of the edges meet. So like I said, this one here is considered a pentagonal prism because the bases are pentagons. This one would be a triangular prism because the bases, the congruent parallel faces, are triangles. So we name prisms by their bases. So if you look at this example, this would be called a rectangular prism because you have different rectangular bases here. So I could look at the two sides as the bases, meaning I have two congruent parallel rectangles as the sides, so those could be my bases. I could look at the front and the back of this and say, well, now I'm looking at the front and the back as the congruent rectangles that are parallel, or I could look at the top and the bottom as the bases. So a rectangular prism is kind of the exception because really any way you turn it, any way you look at it, as long as you're looking at the two congruent polygons or two congruent rectangles that are parallel, those are your bases. And then all of the other faces that connect those are the lateral faces. So rectangular prism, different things that you can call the bases here. So this is just a rectangular prism. And this is your most common one. A box, you guys have seen a lot and find the volume of these, length times width times height. So this is a very common 3D figure that we talk about. And then we look at these other ones here. So again, here's my base. My two unique bases or faces are the bases. These are congruent and parallel. So this is a pentagon. So this would be a pentagonal prism. And then we look here, well, here's my two congruent faces. So these must be the bases. They're parallel to each other. So those are hexagons. There's 6 sides there. So this is a hexagonal prism. So that's the one main thing here is a prism having the two congruent parallel faces. Now remember, there's such thing, we have pyramids, cones, cylinders, spheres, all those other objects we'll talk about. They're not all considered prisms because they're not made up of polygons with two congruent parallel bases. So we'll talk about those, but they're not considered a prism. So looking at the next topic here, the next idea is when we talk about a cross section. So this kind of goes with our vocab because what's going to happen is you're going to see some three-dimensional shape, and if you talk about a cross section, what you really have to imagine is taking this three-dimensional figure, so in this case this rectangular prism, and slicing it. So doing a straight slice right through it. So you can't do like a like a slice and then turn it. It's got to be just one complete slice right through it. So imagine like putting a piece of paper right through the object. The cross section is going to be whatever two-dimensional shape you're left with. So if you imagine in this cross section here, you would, if you were to take this, slice it, and break it apart, what you would see would be a rectangle or a square, depending on if all 4 sides are equal. So in this one, I'm just going to say a rectangle. It may be a square, but I don't know that those 4 sides are congruent. And then if I look at this one, if I imagine slicing right through it, so this is going to be kind of what you're going to see. You're going to see if you were to, again, break it apart, you would see a triangle. So really the idea here is if you're doing a cross section or you're slicing your prism so that you're slicing it parallel to the bases, you're going to get out whatever shape the base is. Now, we will talk more about in class what happens if you start slicing this at an angle. So meaning you're going to do one slice diagonally through this. You're not going to necessarily get out the same shape as the base. So we'll talk more about that in class so you can visually see that. But for right now, just kind of get the idea of if you slice parallel, you're going to get parallel to the base. So it's what two-dimensional shape do you see? And we'll deal more with that later. And then the last topic here is a net. So a net you've done stuff with in middle school, and it's basically you start with a flat shape and you have to imagine folding it and building it to become this three-dimensional figure. So if I look at this pentagonal prism, because I have pentagons for bases, I want to know which one of these things could I fold along all of the edges and actually create this picture. Well, the thing, first of all, is you have two pentagons as bases, and then all of these other shapes are rectangles. So when I look at it, this has one pentagon base. These two bases are hexagons, so this can't be the picture. And if I look at this one, I have two pentagonal bases and all of these rectangles that connect to them. So basically, if you imagine folding on this edge here, that's going to be the top and the bottom of your figure. This will be one face. This face is going to connect to these two sides. This face right here would connect to these, and then continue that idea that this rectangle is going to connect to those when you fold, and then this rectangle will connect to those sides there. So this is going to be the answer because it has two pentagonal bases with rectangles acting as the lateral faces. So it's basically just a flat figure that you would fold and create this three-dimensional figure. That's what a net is. So go ahead, get some key ideas written down, probably something from each of the different topics, and then we try to check your understanding problems, and we will do more with these ideas in class tomorrow.